Hey everyone, welcome to my channel. So in this video I'm going to try to solve this problem, and at the same time I'm going to follow the general interview steps while trying to solve it. So first of all, let's read through this question to get a good understanding. So minimum difference between largest and smallest value in 3 moves. So given an array nums, you're allowed to choose one element of nums and change it by any value in one move. So return the minimum difference between the largest and smallest value of nums after performing at most 3 moves. So let's say we have the array containing 4 numbers, 5, 3, 2, 4. Then we are going to output as 0. That's because we can change the array to containing identical numbers. So we change 5 and 3 and 4 into 2, and then the diff between the max and min is going to be 0. Okay, so essentially the question is asking about we could randomly select 3 numbers from the array, change them to anything we want, but the thing we want finally is the minimum difference between the largest and smallest numbers in the array. Alright, so let's see the constraints. So it says the length of the array is anywhere between 1 to 100k, and then each number is between negative 1 billion to positive 1 billion. So having said that, let's think about the edge cases. So the edge case I can think about is if we contain 1 number, 2 numbers, 3 number, 4 number, which means smaller than or equal to 4 numbers, then we can change the array into identical. Then for sure it's gonna be 0 as the output value. So let's see how to solve the general cases. So when I mean general cases, it means we have more than 4 numbers in the input array. So let's see how to solve the general cases. So the first way I can think about is kind of brute force. Since it is asking us to find the diff between the largest and smallest thing, it reminds me to do the sorting first. So let's say the first brute force solution is about sorting. So let's take an example. Let's say we have example 2 as the input. Then after sorting, the array is gonna be like 0, 1, and 5, 10, and 14. So after sorting, we can change any of the 3 numbers into anything. But essentially, although it says just change 3 of the numbers, it's pretty much the same to me, just to remove 3 of the numbers from the array, because we don't want to change the number to be anything worse. So for example, we don't want to change the 1 into a billion, so that's not going to help us find the final answer. So let's say if we just remove 3 of the numbers from the array, then what we could do is like we don't really need to do the move. So essentially what we do is we just remove the number. So so for this question, it's just identical whether we do the number change or we remove the 3 numbers. So let's say we have the array sorted. So we have 4 different ways to remove 3 numbers from the array. So when I say 4 numbers, that is because we don't want to remove the numbers in the middle, because it's not going to help. So let's say we want to, if we remove 1, 5, and 10 from the array, it's not going to help us because we leave the largest number and the smallest number in the array. So that's not going to help us find the final answer. So instead, what we want to do is we want to remove the smaller numbers, which means the beginning of the array, or we want to remove the larger numbers, which means the end of the array. So we could choose 3 of the numbers from either side or some kind of combination. So let's say we remove 3 small numbers, then we have the array left as 10 and 14. So if we remove 2 of the small number and 1 large number, then we have 5 and 10. And similarly, we could have 1, 5 left, and if we remove all of the large numbers, all 3 large numbers, then we have 1, 0 left there. So of course, the smallest diff between 4 choices are going to be the last choice, which is 0 and 1. So in that way, we can solve the general cases. So the runtime is going to be a log n. That is because we are going to do the sorting. So n is the length of the array. So since we mentioned that we just remove the 3 numbers either from the beginning or from the end, it makes me so it feels to me that we don't really need to sort the entire array. So instead, what we need to do is we just need to find the 4 of the smallest numbers and the 4 of the largest numbers, and then mimic the process we do the number removal. So in this way, let me repeat that. So if we look at the optimal way to solve this problem, essentially the first step we need to do is we need to find the 4 smallest and 4 of the largest numbers. That's the first one, and then we just mimic the steps we talked about. So the step we talked about is about like, for example, we have 4 of the smallest numbers. So let's say we have S1, S2, S3, and S4, and via L1, L2, L3, and L4. So S2, S1, 2, 3, 4 are the 4 of the smallest numbers. L1 to 3, 4 are 4 of the largest numbers. So they are all sorted in ascending order. So like I said, we could mimic the process above. Like we remove all the 3 smallest numbers, or remove the two small number, 1 largest number, so something like that. So that leaves us 4 of the choices. If we remove 3 of the smallest one, then we have the diff as L4 minus S4. So if we remove two small one, 1 large one, then we are looking at L3 minus S3. So if we remove 1 small and the 2 large, then we are looking at L2 minus S2. And then if we remove all the 3 large numbers, then we are looking at L1 minus S1. So we could just find the smallest one among all of the 4 different choices here. So here we are looking at the runtime as linear. That is because to find the 4 smallest and largest numbers, it is going to take us linear time. And the second step, mimicking the step we talked about, it is going to be a constant runtime. So to find the 4 of the smallest or largest number, it reminds me us to use priority queue to solve this question. So having said that, I think we have everything to get us to do the coding work. So let's start to do some coding work on top of it. So first of all, like I said, do some edge case checking. If nums.length is smaller than 5, then we're just going to return 0. Otherwise, we are going to have the priority queue. So we have the first priority queue as a main heap. We don't need to do anything special. Priority queue. We have the priority queue containing 4 numbers, and then the second way, we are going to define the max heap. So the large numbers we get from the main heap. For the smallest number, we get from the max heap. So we have 4, and this one we need to have collections dot reverse order. And then the next step is we try to fill the max heap and min heap, and at the same time we make sure the size of the heap is going to be 4. So we go through the numbers within nums array, insert it into the heap. So we will say, okay, min heap dot add num and max heap dot add num as well. And in case the size go over 4, we need to remove numbers from that. So if the size is larger than 4, then we need to say, okay, min heap dot pull max heap.pool. Alright, so that's pretty much it to find the smallest and the four smallest and the four largest numbers. Then we need to define the thing we talked about. We have the smallest as new int 4, and similarly we have the largest as new int 4 as well. And then we go through everything left in the heap, so as smaller than 4 plus I. So for the largest one, so for the smallest one, we want it to be sorted, and it is gonna be from the max heap. So the top element from the max heap is gonna be the largest one. So it's gonna be the largest one. So in this case, it's gonna be 3 minus I. So we want the smallest one to be sorted in ascending order. So that means we are going to fill this array in reversely. So you have max heap.pool. So for the main heap, is going to be in ascending order. So we have the largest I as main heap.pool. Alright, so that's it. And then we have the, let's say we define the min diff as equal to integer.max value. It goes through all the 4 different choices like I talked about. So min diff is equal to max.min diff. This would be largest I minus smallest I. And finally we just return min diff. So for simplicity, I'll just rely on this platform to help us do the debugging work. So first task case works. Let's do more of the task cases. Alright, so it seems like everything works well. So that's pretty much it for this solution. So if you have any question regarding the solution or regarding the piece of code, feel free to leave some comments below. If you like this video, please help subscribe to this channel. I'll see you next time. Thanks for watching.